People tend to have a notion of high-level and low-level languages, but nobody can really agree on where the line should actually be drawn. Most people agree that something like JavaScript is high-level, but what about C? I would classify it as low-level, but that's definitely not the traditional definition. There's a huge number of different languages out there, and they span a huge gamut of different styles. So let's get into where these lines should actually be drawn. If you'd consider Java to be high-level, but C++ low-level, then you probably see high-level languages as managed ones. A managed language is a language that has a heavy runtime that your code will sit on top of, rather than sitting directly on top of the CPU. Typically, this involves garbage collection, array bounds checks, exceptions, and a complex dynamic typing system at runtime. These sort of things show up in Java, C#, Python, and plenty more. But this is a pretty flawed notion, as unless you're specifically doing some sort of freestanding programming, the OS will be a big part of your program, even if you don't realize it. Additionally, languages that still are, by most other definitions, low-level, still often have runtimes. For example, Odin's reflection is only possible because of the runtime, and not many people would argue that Odin and JavaScript are at the same level, while C is below both. Odin's reflection is also super cheap. There's no information attached to the values themselves. The compiler just spits out a few kilobytes of information stored in a table statically inside your binary. Reading that information out is quick and is very isolated from the rest of the language. Even still, this isn't necessarily a well-defined distinction. C is the programming language, it's a C compiler, but with an explicit goal to provide memory safety, it injects checks for almost every single thing that could cause undefined behavior. And it bundles a full garbage collector too. Does this make C a high-level language just because a compiler exists, which includes a full runtime? Definitely not. Really, a language's runtime doesn't have all that much to say about whether it's high-level or low-level. It can often just be an implementation detail the users don't even think about. So, if the line between runtime and runtimeless is blurry, and runtimes can be added into languages that don't require them, what's a more well-defined way to distinguish between high and low level? Calling back to the original meaning of a high-level language, we might consider C to be high-level and assembly low-level. The idea here is that C defines the effect that your code can have, but not the implementation of them. This means that one person can program a C compiler for an ARM CPU, and another can program one for an x86-64 CPU, and if they both properly follow the standard, any well-formed C code can run on both CPUs with identical behavior. This is a pretty big difference, because ARM and x86-64 machine code look quite different, so it's unlikely you'd be able to port them directly. Assembly makes this a little easier, of course, but not by a lot. The issue is, though, outside of assembly and machine code, basically every language on the planet is hardware agnostic these days. Tools like LLVM make this a lot easier for compiled languages, though whether that convenience is worth it is up for debate. And interpreted languages are generally implemented inside of other hardware agnostic languages, so that comes for free. Interestingly, not all assembly languages are hardware specific. WebAssembly is a language that does effectively function as an assembly language, serving as a simple, flat compilation target, consisting of a linear flow of opcodes and operands. But it's still pretty abstract. It's targeting a virtual architecture designed to run inside of specific WASM runtimes, like one bundled inside your web browser. It's super sandboxed though, since it needs to be safe, and it can run basically anywhere. It also doesn't deal with registers, like you might expect from an assembly language. It's stack-based, like a lot of higher-level bytecode languages. You could argue that WebAssembly is just poorly named, but I think there's a real argument that it's a full assembly language that's also somewhat high-level and extremely portable. Saying that all C code would run the same, regardless of CPU, has one big caveat. It assumes that the same functions exist across all targets. This is true for the C standard library, since it's standardized alongside the language itself. But to do anything interesting on a computer these days, you're going to need an operating system's API. Unfortunately, what an OS's API actually is also a bit of a blurry line, especially on Linux. Regardless, it may be the right place for us to define what a high-level language actually is. So, perhaps the distinction is that high-level languages allow you to write code without worrying about the operating system. Well, if we look at a language like Java, it originally marketed itself with write once, run anywhere. The thing is, the ability to run the same code anywhere really doesn't depend on the language itself, and more so the ecosystem. Java provides things like cross-platform windowing, graphics, input, and audio inside the standard library, but there's no real reason the same thing couldn't be done in C. In fact, a large amount of the C standard library does do this. Even though windowing and graphics may be flashier, reading and writing files is the exact same process of abstracting over the more fundamental operating system APIs. Furthermore, there's no reason you couldn't call out to an OS API from Java. Using the Java native interface or the newer foreign function in memory API, it's trivial to call out to functions defined in C, like an OS API. Even furthermore, things like graphics APIs aren't cross-platform at all. While it's not exactly common to use something like DirectX or Metal from inside Java, there's no reason you couldn't. Any language that does want to provide something cross-platform is going to need to juggle graphics APIs regardless, which typically requires going pretty abstract, with something like JavaScript's Canvas 2D API. There are some things, like OpenGL, that can generally be assumed to exist wherever you need them to, but macOS has deprecated OpenGL and isn't developing any new versions, so if you want to do modern graphics, you're going to need to use an abstraction. In fact, native windowing on Linux is a hurdle on its own. There's no one well-defined system for it. If you want an application that just works across almost every Linux distribution, you're pretty much forced to use SDL. There's just no other reasonable alternative. Speaking of SDL, it's just as cross-platform as Java's APIs, fully implemented in C. Ultimately, there's really no way to define a language as operating system agnostic. An OS API stretches through the full scope of what an application may need, and even if there's some common set of things that are supported across most operating systems, it's perfectly reasonable for any sort of application to want to call out to a specific OS function. There's a huge hole in this entire video, and that's Lisp. There's really no good way to categorize it. You may intuitively think of Lisp as a high-level language, since there's really no connection to standard hardware, and it famously has incredibly powerful metaprogramming and code manipulation, not the sort of thing you would expect to see in a low-level language. Yet still, it's more than 20 years older than C, and it pioneered a lot of tricks with compilers. Additionally, there used to be Lisp machines, computers with hardware specifically tailored to running Lisp, so in that sense, it's lower level than C. So, turns out there's no good way to define this stuff. I think the best example of this is the Rust language. It's low level in a way, it has the performance you'd expect from a language like C, but it's got automatic memory management, compiler-guaranteed safety, and a standard library with heavy usage of closures, iterators, method chaining, and other things that are more common in a language like JavaScript. Is Rust confused, or are we just using confusing categories? Either way, it's not a very useful categorization. High level versus low level is arguably a mindset more than anything else, and almost any language can be written in either way. Some languages are, of course, more conducive to writing high-level code, like Python, Ruby, JavaScript, or Bash, and some languages are the opposite. Languages like C, Zig, or Odin are designed to make low-level code come naturally. Still, when working with something like WebGL, or the newer WebGPU, you are effectively writing low-level JavaScript, and it's not hard to write Odin code like it's a high-level scripting language, which is pretty common for a lot of people. With libraries like Raylib and C, you're again basically writing high-level abstract graphics code, but still fully within C. You'll generally get more mileage out of using more specific terms. C is a procedural language with a thin runtime, manual memory management, and no safety guarantees. Java, on the other hand, is an object-oriented language with a hefty runtime, garbage collection, and runtime safety guarantees via restricting your direct control over the hardware and adding lots of checks through the runtime. There's also a whole category of languages I didn't get into, like TCL and Lean, languages with specific purposes and designs specifically tailored to certain types of programs. TCL is a really weird one, since everything, including your own code, is a string at runtime that you can modify. It's certainly abstract, but it doesn't really fit into the traditional hierarchy. Lean is loosely functional, with heavy usage of pattern matching and things, but it's also full of non-ASCII mathematical symbols, as well as first-class language concepts of theorems and hypotheses and more. It's really a language specifically tailored to raw mathematics beyond anything else. There's also esolangs, or esoteric programming languages. Languages created with niche, specific, and often strange goals and design choices. Like TCL, they're certainly abstract, but it's not necessarily fair to say that they're high or low level. For example, brainfuck is a language that simulates a Turing machine. In a sense, it's incredibly low level, since you're operating on individual bytes, and your only operations are moving, incrementing, decrementing, I/O, and jumping. Still, brainfuck has no memory management and no OS-specific code. You just write the instructions and the interpreter or compiler figures out how to handle the memory and things. Does that make it high level? If you learned something from this video, I hope you'll leave a like, and subscribe if you want to see more. That's all for now, and I'll see you next time.